NASA images reveal something that is forcing scientists to rethink everything. There are images that expand our understanding of the universe, and there are images that quietly dismantle it. This is one of them. Somewhere in the vast silence of space, far beyond the reach of our instincts and intuition, a telescope operated by NASA captured something that should not exist according to everything we believe about the cosmos. At first, it looked like just another distant structure, a faint signal, a pattern of light stretched across billions of years, nothing unusual in a universe already filled with wonders. But then, the details began to emerge. The shape was wrong. The timing was wrong. The formation itself defied the very rules that have guided modern astrophysics for decades. And the more scientists looked at it, the more uncomfortable the silence became. Because this was not just an error, not a glitch, not a misinterpretation. It was consistent, repeated, verified. And now, a question is beginning to take shape inside the scientific community. Not loudly, not dramatically, but in quiet conversations, in reanalyzed data, in cautious papers that hesitate to say too much too soon. What if the universe is not behaving the way we think it is? In this video, you are not just going to see images from space. You are going to follow a trail of evidence that starts with a single observation and leads to a possibility that could reshape everything we understand about reality itself. And it begins with a moment that should not exist. The moment that shouldn't exist. This image should not exist. Not here, not at this time, not under these conditions. And yet, it does. What you're looking at is light that has traveled for more than 13 billion years, crossing the entire observable universe just to reach us. A message from a time when the cosmos was still young, chaotic, and not yet fully formed. According to everything we understand, structures at this stage should be small, unstable, and incomplete. The universe, in its infancy, simply did not have enough time to build anything complex. But this image shows something else, a structure that appears far too organized, too large, too mature, as if the universe had already accelerated its own evolution. At first, scientists assumed it was a distortion. Gravitational lensing can bend light, stretch it, magnify it. It can make distant objects appear larger or stranger than they truly are. But even after correcting for these effects, the anomaly remained. The object did not shrink into something expected. It stayed impossible. And that is where the discomfort begins. Because in science, a single anomaly can be ignored. It can be explained away, placed aside, or attributed to uncertainty. But when an observation survives every attempt to dismiss it, it becomes something else entirely. A signal, a crack in the system. And if this is a crack, then the next question becomes unavoidable. What else might be breaking beneath the surface of everything we thought we understood? What we thought we knew. Before this image, the universe followed a story we believed we understood. Not perfectly, but well enough to trust its direction. For decades, cosmology has been guided by a simple idea. The universe began in a hot, dense state, expanded, cooled, and slowly organized itself into the structures we see today. Galaxies did not appear fully formed. They emerged gradually, shaped by gravity, time, and the invisible scaffolding of dark matter. There was a sequence to everything. First, tiny fluctuations in energy, then clouds of gas collapsing under gravity, then the first stars igniting, spreading light into a universe that had once been completely dark. Only much later did galaxies grow large, stable, and complex. Time was the essential ingredient. Nothing rushed, nothing skipped ahead. And this understanding was not built on guesswork. It was supported by observations, simulations, and decades of data collected by missions led by organizations like NASA and other space agencies around the world. Every new discovery seemed to reinforce the same narrative. Until now, because the image you just saw does not fit into this timeline. It does not belong to the early chaotic universe we expected. It looks like something that should exist much later, after billions more years of evolution. And that is the problem. If the universe truly follows the rules we believe in, then this structure should not have had enough time to form, not with the known laws of physics, not with the known rate of cosmic expansion, not with the known ingredients available in that era, which leaves us with an uncomfortable possibility. Either this is a rare exception, or our understanding of how the universe builds itself is incomplete. And when a model begins to fail, Even in a single place, it forces a deeper question to emerge, not about the anomaly itself, but about the foundation beneath it. Because if this is not an exception, then something much more profound is waiting to be uncovered. And that is where the first real crack begins to show, the first crack in the system. At first, it seemed like an error. That was the most comfortable explanation, the safest one. A distortion in the data, a calibration issue, a misinterpretation of light that had traveled too far, for too long, through a universe that bends and warps everything it touches. Instruments are not perfect. Even the most advanced observatories operated by NASA rely on layers of correction, interpretation, and reconstruction. What we see is never the raw universe, but a translation of it. So the image was questioned, reprocessed, reanalyzed, cross-checked. Different teams looked at the same data. Different methods were applied. Independent verifications were performed, each one attempting to find the flaw, the inconsistency, the hidden mistake that would return everything to normal. But the image did not change. The anomaly remained exactly where it was, not shifting, not dissolving, not revealing any hidden error. And slowly, almost reluctantly, the conversation began to change. Because if it wasn't the instrument, then it had to be the interpretation. Maybe the object was closer than expected. Maybe the redshift had been miscalculated. Maybe the light had taken an unusual path, distorted in a way that created an illusion of structure where none truly existed. So they tested that too. They adjusted the distance, recalculated the timelines, simulated alternative scenarios, and again, the result refused to cooperate. No matter how the data was approached, the conclusion remained the same. This structure existed too early for the universe we think we understand. And that is when the first real crack appeared, not in the image, but in the confidence behind the models. Because science does not break all at once. It fractures slowly, beginning at the edges, where certainty is weakest. And when something survives every attempt to explain it away, it stops being an anomaly. It becomes evidence. And now, something deeper is beginning to unfold. Because this was never just about one image. It was about what that image represents. A possibility that the universe may not be following the script we wrote for it. And if that is true, then this is only the beginning. It wasn't just one image. If this had been a single observation, it could have been contained, labeled as unusual, filed away as an outlier, something to revisit later, once better data became available. That is how science protects itself from rushing into conclusions. But that is not what happened. Because soon after that first image, another appeared, and then another. Different regions of the sky, different observation windows, different instruments, sometimes even different missions. And yet the pattern was disturbingly familiar. Structures that seemed too large, too organized, too evolved for the age of the universe they belonged to. It was subtle at first. Not identical copies, not obvious repetitions, but echoes. Variations of the same contradiction appearing in places that should have had no connection at all. And this is where the tension began to deepen. Because independent observations are supposed to correct each other. If one dataset contains an error, another will expose it. If one instrument distorts reality, another will reveal the truth behind it. But in this case, the opposite was happening. The more we looked, the more consistent the anomaly became. Even data coming from advanced observatories like the James Webb Space Telescope began to hint at the same unsettling possibility. Galaxies appearing earlier than expected, structures forming faster than our models allow, light revealing a universe that seems ahead of itself. And now, the question is no longer about a single image. It is about a pattern that repeats across time, across space, across different methods of observation. And patterns are harder to ignore, because patterns suggest something deeper, something systemic, something that is not caused by error, but by reality itself behaving in ways we do not yet understand. At this point, the anomaly is no longer isolated. It is spreading. And with every new observation, the margin for dismissal becomes smaller, which leads to a quieter, more unsettling realization. This may not be a mistake. It may be a message hidden in the structure of the universe itself. And now, scientists are beginning to respond, not with certainty, but with caution. Because what comes next is not announced loudly. It unfolds in silence. The silent reaction of scientists. There was no dramatic announcement, no urgent press conference, no declaration that everything we know is wrong. Instead, something much quieter began to happen. Researchers went back to the data. again and again. Papers were revised, models were adjusted, language became more careful, more restrained. Words like unexpected, unusual, and requires further investigation began to appear more frequently in scientific publications, not as conclusions, but as signals. Because in science, hesitation often speaks louder than certainty. Teams working with observations from NASA and other institutions did not rush to rewrite the laws of the universe. That is not how science works. It moves slowly, deliberately, testing every possibility before accepting something new. But something had changed. You could see it in the way data was being treated. Instead of dismissing the anomalies, scientists began to explore them more seriously. Alternative models were considered. Simulations were rerun under different assumptions. Parameters that were once fixed began to shift, quietly, carefully, as if no one wanted to be the first to say what might be unfolding. Because acknowledging a real inconsistency does not just affect one observation. It ripples through everything connected to it. Cosmology is not built on isolated facts. It is a network of ideas, each one supporting the other. And when one part begins to weaken, the entire structure feels it. That is why the reaction has been so measured. Not because the anomaly is insignificant, but because of what it could imply. If these observations are correct, then something fundamental may need to be reconsidered. Not discarded, not abandoned, but re-examined at its core. And that process does not happen in headlines. It happens in silence, in long nights of analysis, in cautious discussions between experts, in papers that ask more questions than they answer. Because the truth is, no one wants to rush into rewriting the universe, but no one can ignore what they are starting to see. And as the data continues to accumulate, one thing becomes increasingly difficult to avoid. This is not just strange, it does not make sense. What doesn't make sense? The deeper you look into these observations, the harder it becomes to fit them into anything familiar. It is not just one detail that feels out of place, it is several, and they all point in the same direction. Light, for example, is supposed to follow very precise rules. It travels across space, stretched by expansion, shaped by gravity, carrying with it a clear record of where it came from and how long it has been traveling. That record is one of the most reliable tools we have. But in these images, the light tells a story that does not align with the structures we see. According to the data, these objects belong to a very early period of the universe, a time when matter had only just begun to organize, when stars were still forming and galaxies were small, irregular, and unstable. Yet what appears in the image looks far more developed. The distribution of matter is too structured. The brightness suggests a level of activity that should not yet exist. The shapes resemble systems that require far more time to evolve. It is as if the universe is showing us something that belongs to a different stage of its own history. And then there is the question of formation. To build something this large, gravity needs time. It needs billions of years to pull matter together, to stabilize it, to create the kind of complexity we are observing. But the timeline does not allow it. Not even close. Even when scientists push the limits of current models, even when they adjust variables to their extremes, the gap remains. The structure forms too early, grows too fast, and stabilizes too quickly. And then there are signals coming from regions that should be nearly empty. Areas where the density of matter should be too low to support anything significant. Yet somehow, something is there. Not faint, not insignificant, but detectable in a way that demands attention. Each of these details on its own might be explained, but together they begin to form a pattern of contradiction, a pattern that resists simplification. Because this is not just about something unusual, it is about something that does not behave the way reality is supposed to behave. And when reality itself starts to feel inconsistent, the question becomes unavoidable. Are we missing something fundamental, or are we looking at the first signs that our understanding is incomplete? Theories that don't hold. When something does not make sense, science does what it always does. It tries to explain it, carefully, methodically, without abandoning what already works. The first possibility was the simplest: instrument error. Perhaps the sensors had misread the signal. Perhaps the data had been distorted during transmission. Perhaps something in the processing pipeline had introduced a pattern that was never really there. So the data was checked, then checked again. Independent teams reviewed it. Alternative calibration methods were applied. Observations from different instruments were compared, including those linked to missions supported by NASA. and the result remained unchanged. The anomaly persisted. So, the next explanation emerged: misinterpretation. Maybe the object was not as distant as it appeared. Maybe the redshift, the key indicator of distance and time, had been calculated incorrectly. If the object were closer, it would no longer violate the timeline. So they recalculated, adjusted the models, tested different assumptions, simulated alternate scenarios. But each time, the conclusion circled back to the same point. The object was exactly where it seemed to be, exactly as old as the data suggested, and still too developed. Then came a more flexible idea. Perhaps our models of early galaxy formation were incomplete. Maybe structures could form faster under certain conditions. Maybe dark matter behaved differently in the early universe. Maybe there were processes we had not yet fully understood. This explanation was not dismissed. It was explored. Simulations were pushed to their limits. Variables were stretched. Extreme conditions were tested. But even then, something did not fit. The growth required to produce what we are seeing still exceeded what the models could realistically generate. And that is where the tension reaches a new level, because one by one the explanations begin to collapse. Not dramatically, not all at once, but gradually, as each possibility fails to fully account for what is being observed. And when that happens, science reaches a difficult moment. Not a conclusion, a threshold. The point where the question is no longer how to explain the anomaly within the system, but whether the system itself needs to be reconsidered. Because if every explanation fails, then something deeper must be wrong, not with the data, but with the way we understand reality. And that is where the next question begins to form. A much bigger question emerges. At some point, the focus shifts. It is no longer about the image, not even about the anomaly itself. It becomes about something far more unsettling: the framework behind it. Because every scientific model is built on assumptions, not guesses, but deeply tested principles that have held up under countless observations. They form the foundation of how we interpret everything we see. And for a long time, that foundation has been remarkably stable. The universe expands, gravity shapes structure, time allows complexity to emerge. Cause leads to effect in a sequence that feels consistent, predictable, understandable. But what happens when an observation refuses to follow that sequence? What happens when something appears that seems to skip steps, to arrive too early, to exist outside the expected order of things? That is where the real question begins. Not, what is this object? But, what does this say about the rules we believe in? Because if the universe can produce structures that should not yet exist, then either there are processes we have not discovered, or the timeline itself is not as straightforward as we thought. And that possibility changes everything. It suggests that what we call understanding may only be a partial map, that the equations we rely on describe a version of reality, but not necessarily all of it. And suddenly, the anomaly stops being an exception. It becomes a clue that something deeper may be operating beneath the surface of what we can currently explain. This is the moment where science becomes something else, not just a collection of answers, but a confrontation with its own limits. Because if this is true, then the implications extend far beyond a single observation. They reach into the origin of galaxies, the behavior of time, the nature of space itself. And once that door is opened, it cannot be easily closed. Because now a new kind of question is emerging, not about what we see, but about what we might be missing. What could this mean? Once the possibility is accepted that something does not fit, the mind begins to search for new paths, not conclusions, possibilities. Because if the current models cannot fully explain what we are seeing, then there are only a few directions left to explore. One of them is that the universe may have evolved differently than we imagined. Perhaps the early cosmos was not as slow and gradual as we believed. Maybe under certain conditions, structure could emerge far more rapidly, driven by processes we have not yet observed directly. Mechanisms that accelerated formation, compressing what should take billions of years into a much shorter span. Another possibility is even more profound, that the physics we rely on is incomplete. Not wrong, but unfinished. There may be forces, interactions, or behaviors that only reveal themselves under extreme conditions, hidden from us until now because we had never looked deep enough or far enough back in time to see them. And then there is a more subtle idea, that what we are observing is not the universe behaving differently, but our perception of it being limited. Light does not just travel, it transforms, it bends, It interacts with space itself. What we see is always a reconstruction, a delayed image shaped by everything it encountered along the way. So perhaps the anomaly is not in the object, but in the path the light has taken to reach us, a distortion not of the object's nature, but of its story. And yet, even these possibilities do not fully resolve the tension, because each one introduces new questions. If structures can form faster, what allows that acceleration? If physics is incomplete, where does it begin to change? If observation is limited, how much of reality are we missing? And this is where the mystery deepens, because every explanation opens another layer of uncertainty, not closing the gap, but expanding it. And in that expansion, something remarkable begins to take shape, a realization that the universe may not just be more complex than we thought. It may be more surprising than we are prepared to understand. The universe. We haven't seen yet. There is a quiet truth that follows every discovery. The more we see, the more we realize how little we understand. For a long time, we believed we were approaching a complete picture of the universe, not in detail, but in structure, a framework solid enough to explain where everything comes from, how it evolves, and where it might be going. But moments like this reveal something different. They show us that what we call knowledge is still unfolding, because the universe is not obligated to match our expectations. It does not adjust itself to fit our equations. It reveals itself slowly, in fragments, often in ways that challenge the very tools we use to understand it. And perhaps that is what makes this moment so important. Not because it gives us answers, but because it reminds us that we are still at the beginning. What if these images are not anomalies, but glimpses of a deeper layer of reality? A layer where the processes we know are only part of a much larger system, where time, structure, and formation do not follow the patterns we assumed. What if the universe we have been observing is only a surface? And now, for the first time, we are starting to see beyond it. Because every time we build a better instrument, every time we look farther into space, we are not just extending our vision. We are entering unfamiliar territory. And in that territory, the rules may not feel the same. The idea that the universe is fully understood begins to fade. In its place, something far more powerful emerges, a sense of openness, a recognition that discovery is not about confirming what we already believe, but about being willing to see what we did not expect. And now, with these images, we are standing at the edge of that realization, looking into something that feels both familiar and completely unknown. Which brings us back to where this all began. Not with an answer, but with a single image. Return to the image. Now, look at it again. The same image. The same light that traveled across billions of years. The same structure that seemed, at first, like just another distant object in an already overwhelming universe. But it does not feel the same anymore, because now you are not just seeing it. You are understanding what it challenges. What once looked like a distant formation now carries weight. It holds questions. It represents a tension between what we expected to find and what is actually there. The size is no longer just impressive. It is problematic. The structure is no longer just beautiful. It is out of place. And the timing, that is where everything becomes impossible to ignore. Because this image is not just showing us something far away. It is showing us something out of sequence. A piece of the universe that seems to have arrived before it was supposed to exist. And that realization changes the way we look at everything around it. Other images, other data, other assumptions that once felt secure now begin to feel provisional. Because if this one observation holds true, then it becomes harder to trust that everything else fits perfectly into the model we built. And yet, this is where the power of science reveals itself. Not in certainty, but in its willingness to return to the evidence, to look again, to question again, to allow a single image to reshape the direction of inquiry. Because this is not just a picture, it is a turning point, a moment where observation and understanding begin to separate, creating a space where something new can emerge. And now, standing in front of this image again, the question is no longer what we are looking at. The question is what we are ready to accept. The final question. There is a moment in every journey of discovery where the answers begin to matter less than the questions they leave behind. This is that moment, because what started as a single image has become something far greater. Not a conclusion, Not a breakthrough we can fully define, but a shift in perspective. A quiet recognition that the universe may not be as settled as we once believed. And that realization carries weight. Not because it tells us something is wrong, but because it suggests something is still hidden. We have spent generations building a map of the cosmos, expanding it, refining it, trusting it. And for the most part, it has guided us well. It has revealed galaxies, explained motion, predicted phenomena we later confirmed. But a map is not the territory, and sometimes what we discover is not a new destination, but a sign that the map itself is incomplete. So now, we are left with something more powerful than certainty. We are left with possibility. The possibility that there are layers of reality we have not yet uncovered. That time, structure, and formation may behave differently under conditions we are only beginning to observe. That what we call understanding is still in progress. And that brings us to a question that does not close this story, but opens it even further. If the universe is showing us something that should not exist, is it the universe that is breaking the rules, or is it us finally beginning to see beyond them?